All right, all set.
Yep.
All right. Well, hello everyone. I'm Christopher. You guys kind of know me. The president of VFS. I'm gonna give you a little talk today about 3D printing and additive manufacturing. It's a pretty necessary tool when it comes to design teams for rapid prototyping and manufacturing parts. Um, So I'll give you kind of a walkthrough. By now you've went through the whole CADing stage. You kind of understand now how to start CADing parts. Now it's time to bring those parts to life. And one of those ways we can do that is with 3D printing. So I'll walk you through the whole process of going from, your SolidWorks design part all the way to something that's ready to be printed. All right. So kind of an overview of what additive manufacturing really is. And in fact, additive manufacturing is kind of an umbrella term for many sub-terms. It's also kind of known as rapid prototyping and 3D printing. Um, Now we're moving away from the idea of rapid prototyping with 3D printing, just as the scalability and quality of 3D printing and additive manufacturing is greatly increasing with technological advancement. It's becoming a more viable tool beyond just rapid prototyping and also just making your final parts. So here's something that I catted up recently. It's a keychain for VFS. It's pretty simple geometry, so it's kind of just to give you guys an idea of how we make this a reality, a real piece. Some go, I'll give you some kind of tips when it comes to design for manufacturing. That's something you'll learn a lot in your engineering careers, is how to have those constraints of how you're going to make something in the back of your mind when you're designing something. So you always kind of have to understand what you want, how you want to build something before you start designing it. So when it comes to 3D printing, there's a few constraints I like to keep in mind, kind of best practice. Especially with our 3D printer, as I was saying, 3D printing is becoming more and more advanced. You can start using them as your final pieces, but the 3D printers we have access to aren't at that level yet. And so I'll probably say that most of the time when we are 3D printing something, it is going to be for prototyping and proof of concept prototypes that we won't actually have in our final design. So when you have that in mind, understand that yes, I'm designing this to be 3D printed, but I know that in the future it's not going to be 3D printed. It's probably going to be made in some other way. So have that in mind when you're going through the design process. Some other things you're going to have to keep in mind, I'll kind of get through when we go through the slicing software. So yeah, here's our part in SolidWorks. I'm done. I'm happy with this part, and now I want to get it printed. What I'm going to do is I'm going to save it as an STL file. That essentially kind of like compresses your file into like a bunch of, surface geometry, kind of complicated computer things. It doesn't really matter. It's just how the slicing software kind of understands it. So I'm gonna save that as a STL file, downloads, save. Yes. Yeah. And so when it's saved as an STL, you're ready to open it up in your slicing software. And so kind of what slicing software is. Think of it like um, a translator. And so what it's gonna do is it's gonna translate this 3D print part into a language that your printer understands, so it knows how to make that part. Um, and what we call this language is G code. And G code is essentially just a bunch of lines of telling where you want your machine to go, kind of. So if you look at a 3D printer, you have your nozzle, and that can move in three directions, your Y, X, and Z direction. And so this G code is going to be a bunch of, complicated code that's going to tell it how much to move in that Y direction, X direction, and Z direction at every move to make this part a reality. Um, if you were to do this by hand, it'd be almost impossible. You do learn kind of how to do it by hand by writing your own G code, but that's for very, very simple geometries, which you're not going to get at all when you're 3D printing something. So let me open up that STL file we just saved. And so now you have this STL file in Creality, I'm sorry, in Cura, and you're gonna get ready to print. Something that's important is that Cura, which is kind of like the market standard for slicing, you have to make sure that you have the right printer ready to print. I have a few printers already installed. These are printers I printed on. The printer that we have in the workshop is the Creality Ender 3 Pro. And so how you make sure you have that printer in Cura is you just go to this tab right here, add printer, and then you go add non-network printer, and you'd kind of scroll through till you found, I think we're Creality 3D, and then the Ender 3 Pro. So that's the printer we have in our workshop. Then after you have your printer all set up, you'd make sure you have the right material. Mostly with the FDM, with the printers we have, we're going to be using thermoplastics like PLA, PETG, thermoplastics like that. ABS, I think we have as well. How you choose your plastic kind of has to do with the material properties of that plastic and the design that you want. That's a little complicated, and that's something that you probably want to discuss with your team before moving forward with the print and doing research on what material is probably the best for your part before you start printing. PLA is kind of the most common material used in the 3D printers that we have. PLA is pretty generic. It's really easy to print with. So I'll just keep PLA for now. Then you're going to kind of want to orient your piece so that it's the best possible way to be 3D printed. Your biggest constraint with 3D printing is gravity. So when you think about it, is that you're kind of adding this plastic on a bed, and then you're moving up layer by layer. So you're adding one layer of plastic, and then you're adding another layer of plastic and another layer of plastic. And this plastic isn't, you know, gonna cool the same way based on like the temperature in the room, what it's being attached to. And there's a lot of things going on. And based on how your plastic is, it'll be affected differently by the gravitational kind of pull. So you want to make sure that you're orienting your piece so that it's gonna feel least amount of effects to gravity. So usually what that means is you're just gonna try to find the flattest piece of your part with kind of no overhangs, and you're gonna kind of try to orient that with the bed of your plate. So here with this one, I'll go to go to the rotate tab, and I'll just kind of drag, and Kira will actually kind of just help me out here and make sure that it's completely flat on the bed there. So you see here, I have like these details on the top, and I have a flat like bed on the other side. That's on purpose that I have this facing the top, because if I were to put this side on the bottom, like I said, you'd have those gravitational effects. This like kind of unsupported like area would be hanging and would kind of dip in, right? Because of gravity. And so yeah, that's kind of what you need to keep in mind when you're getting something ready to print is gravity. It's the most important thing. It's what's gonna, mess up most of your prints. Then we have a few other tools here in Creality. This is the move tool. So if I was printing a lot of things, like a few parts at once, I'd kind of orient them on the build plate just so they would all fit. We're just gonna print one thing here. I also have a scale button. So here you can kind of like do some of the scaling you want based on how big you want your piece to be. Usually we keep it just at 100. You're designing it in SolidWorks for how you want it to be printed already. That's better practice than scaling it in Cura. You can also do uniform scaling. If I wanted to like mess up the geometry and stuff like that. But yeah, best practice is to not scale in Cura and always use 100% scaled. Then you have a few other things like you can kind of like mirror the piece if you wanted to like change how it looked. That these kind of like modifying your parts within Cura is not really good practice. make sure that you have your part ready to be printed in your CAD software before you're getting it ready to generate your G code. So then next, once you have your part oriented how you like, you're gonna go through kind of your print settings, and that's where you're gonna choose how much material is being used, how like quickly you want it to be printed, how nice you want it to be printed, quote unquote, like quality. Usually how we define quality in 3D printing, it's that layer height. And so how I was talking about how you're going to be printing kind of one layer of plastic at a time, how big of difference you have, like the layer height will determine your quality. And so you can think of that as kind of like a resolution almost. Um, if you have a higher layer height, you're gonna have poor resolution. You're gonna have a rougher surface on the outside. While if you have a smaller layer height, you're gonna have better resolution and a smoother surface. Um, that's something that comes into play a lot is like the surface quality in 3D printing. Still, the surface quality is not the best in 3D printing. So if you're designing, two parts that are supposed to be jointed together, you might want to keep that in mind that they might not move in the same way they would if they were, machined out of metal or something like that. So that's kind of the layer quality. I think point two is the most generic. It's the standard quality of most printers. That quality will change based on how nice of a printer you have, like that standard quality. At the Cube here at McGill, which is a 3D printing surface, we have an Ultimaker S5. I think we have a 0.1 standard quality on that printer because it's a little fancier. You can also change the wall thickness. So like when you're 3D printing, you kind of have how kind of to in order to save time and money, you're not going to do a complete 100% plastic fill. It's not going to be a like a fully solid part. What we're going to have is we're going to have a wall which is completely solid. Then on the inside of that part, you're going to have infill. So what it does is it kind of forms this web or grid of plastic inside with air holes, um, so that you can, be the most efficient with how you're 3D printing. Otherwise, it would take super long time and a lot of material and cost to make these 100% kind of full solid pieces. And so that's something that you have to play with a lot when 3D printing is to use the best kind of infill and wall thickness for your part. Um, Usually, I don't change wall thickness. I kind of leave that generic unless I have some very specific prints. Um, and then, yeah, infill is where you're kind of playing with. 60% infill is extremely high. I think standard infill is more around 20%. Um, you can even go as low as 15% infill. But usually when you're printing, especially for rapid prototyping, you really shouldn't have to go above 25%. If you're going above 25%, that's because you intend for your piece to be used for something very specific where it needs to have, more structural integrity, and you're more likely using it for a very, important prototype or for maybe even a final design. Yeah, you can also kind of play with, the speed of the nozzle. That's something that can be a little dangerous and affect your print quality. Most of the time, Cura chooses a good standard speed for you to, print properly. Then the next thing that's really important is your supports. So, how I was saying is that when you're 3D designing for 3D printing, you want to have in the back of the mind in your mind that you're not going to use this final part from 3D printing. You're probably going to use another manufacturing method. That's true, but you also have a lot of freedom with 3D printing in that you can have overhangs. And what an overhang is essentially like you don't have to have your part always be completely flat over the surface. You can have some of the parts that hang a bit. This part doesn't have any overhang, so to speak. But what I can do is I kind of like show you a bit of what an overhang would be. So what an overhang would be was if you have material here and you have no material between it and the build plate. You can still 3D print this. And how you would do that is by generating supports. And supports is just extra material that the software will generate underneath it to kind of hold it up. Think of it like scaffolding for a building, right? It's gonna make extra material scaffolding here to hold up this piece during 3D printing. I'll kind of show you what that generates with this support. So really, the software is really smart, and it's really able to generate good supports, and is actually getting improved upon almost daily. There's daily updates to make this even better and better. And you really don't have to do much in terms of customization with the supports. I'd say most of the time you just toggle on generate support, and it'll give you a very good kind of idea of what it should look like. And then when you're happy with your print settings, that's when you're going to hit slice. And so I've been using this word slice. What slicing kind of means is I was talking about G-code and how this is a translating software. That's exactly what slicing means. It's taking this 3D print and it's hitting that translation, and it's going to cut this piece up into a bunch of different language, which is called G-code, and it's going to be ready to print. And so I'll hit slice. It'll give us a preview of how long it thinks the print's going to take, how much material you're going to use, and the length of that material. And so we can kind of go through pure preview and see kind of what that would look like on the printer. So here, Cura is really smart, and it's able to kind of differentiate the different kind of parts of your design. So in blue here, light blue, that's all of our support. And that's going to make sure that the gravitational effects aren't affecting these overhang material, and it's going to hold the print up. Like I said, this isn't good practice for a piece like this. You'd likely want to have it, flat on your print bed just because of how it is, but you're going to have overhangs sometimes, and that's when you're going to have to generate supports. And you can kind of do some really fancy things here with Cura. You can kind of like play with how the nozzle will go about with like a certain angle. If I on the right here, it's kind of like how many layers it cut this into. So it cut it into 238 layers. So we can kind of like roll back here, kind of see what the printer's kind of doing. So this is kind of like what its first like layer is gonna be. The nozzle is gonna, you know, um, go around. You can kind of watch it. Um, it's gonna be printing out this first layer. And so, yeah, you can kind of verify that the nozzle's going and doing the right thing and how you want it to go and how quickly you want it to go. This is actually real-time speed. This is how fast the nozzle would go in real life. So yeah, Cura is really powerful in that sense, and that you can kind of like go through your whole print and make sure it's doing exactly what you want. Yeah, sometimes I kind of look to see because it's kind of fun to watch. It's pretty slow in person, and it's cool to kind of watch your piece get kind of built before it's even built in person. So here, as I was talking about, is like this infill. So you see inside here, we're kind of forming this grid-like formation, and it's not a fully solid part. We have air in there. Um, like I said, that's for saving time and material. If we had this be completely full, this would take forever. It'd probably be 5 times longer, and you'd probably use 5 times as much material, which is really inefficient and not good practice whatsoever, especially when time and money are super important, especially in design projects. And then, yeah, you see how the wall is kind of like a fully kind of solid piece. So yeah, then when you're satisfied, you kind of like how it's, printed, you like what it looks like. That's when you can like save it to a USB. Um, or sometimes if you have a fancier 3D printer that's already connected to the internet, you can send it directly to the printer over the internet. In the workshop that we have, we're just going to be saving to disk, and then it'll be on a USB. You'll plug that USB into the 3D printer. And then on the 3D printer, you're going to, click find your print, click it, and then just click start like you would on any like a normal like inkjet like printer you have at your house. So that's kind of the whole process of going from SolidWorks all the way to Cura, and now you're ready to print. Now when it's time to print though, there's still a few steps you need to kind of follow when it comes to making sure your print is good and your printer does a good job. There are some calibrations you have to do on the printer we have in the workshop to make sure the nozzle is in the right spot, the build plate is in the right spot. Those calibrations are a little complicated, and that's something that you need to have someone walk you through that knows how to do it. It's a pretty like feely process that you really have to understand your printer to make sure that it's calibrated correctly. Nowadays, though, a lot of the printers are becoming so advanced that you don't really need to calibrate them yourselves. They can actually go through their own calibration algorithms to make sure they're ready to print. Um, so once you feel that your printer's calibrated, that's something, yeah, you'd find kind of an older person in the team that knows kind of 3D printing to make sure that it's calibrated. Or if you have experience, on 3D printing, you know kind of how to calibrate it. You're welcome to do so. Once it's calibrated, there's some good best practice with the build plate to make sure that your first layer, has a good adhesion to the build plate. Because your first layer is the only layer where you have this thermoplastic that's not being attached to other thermoplastic. Afterwards, it's every layer has thermoplastic on each side of it, and the thermoplastic is good at adhering to itself, but it's not good at like sticking to like the build plate, because the build plate's not made out of plastic. And so to make sure you get a really good first layer, there's some just tips and tricks that exist to make sure you have really good adhesion. On the 3D printer on the workshop, what I usually do is I'll take masking tape and I'll kind of add that wherever on this build plate I know it's going to be printed. So it's going to be like in the middle, I'll add a bunch of masking tape in the middle of the build plate in the workshop printer, and then I'll take just some paper glue, like stick glue, and I'll add that all over the masking tape. And that's just kind of been proving to work really well at, giving your first layer good adhesion, and making your print qualities a lot better. Once you have that kind of sticky glue ready to go, that's when you can kind of click start on your print. The printer will heat up the plastic, and it'll get ready to go. It's good to stay for like 4 or 5 minutes to make sure that like first layer prints out nicely, exactly how you want. There are no errors. And then once that's kind of good to go, um, the printer's good to run on its own. Just make sure it has enough material in it, to kind of, finish the whole print. Loading and unloading material, that's something I wouldn't do without the help of someone that knows the printer as well. It can get a little finicky, especially with little lower quality printers like we have with the Ender 3 in the lab. It's kind of like you kind of have to feel your way around loading and unloading material. Um, but yeah, that's kind of like the whole overview on how to 3D print. I know this is kind of just a recording session, but if you have any questions, like feel free to ask me. You can PM me on Slack. I'm always happy to answer. Um, and it's also good to know that the 3D printing community is very open source and really enjoys helping each other. And there's so many resources online on how to print properly, best practices, and how to make your prints even better. So I really recommend being independent in that way. And I think the team would really appreciate if you kind of took initiative as well. So learn on your own. That's always the best way to kind of learn. I learned how to 3D print completely on my own, just trial and error. It's kind of like that's how you kind of learn how you like to 3D print, how you have your own kind of style with printing, and yeah, it's really important in forming that. So yeah, I know maybe Zach or Thomas, they're in the session. If they have anything that they felt I missed or they want to add, they're feel free to add it right now.
That was very well covered. I don't have anything else to add. Again, it's also like a lot of experience and a lot of practice, and also to keep in mind, like something that was very important that Chris said, that is to keep in mind the manufacturing process in our designs. So once we know how we're going to build the piece, we kind of have to design around it. But apart from that, yeah, I agree with everything that Chris said. It was very well presented. So thanks a lot.
All right. I'll stop the recording there.